Welcome to the Calculus A section. Today we'll be discussing optimization. So now we will begin to optimize functions. This section has a large amount of applications in physics, computer science, and engineering, so pay close attention, STEM majors. When we optimize a function, we are looking for the largest or smallest value of a function, subject to a certain constraint or an interval. In order to become a master at optimization, it is important to thoroughly read the problem, as most of the setup, which is the hardest part, lies within the problem. So let's start off with the problem like we do most. We have a step-by-step process on how to solve problems, and that is going to make us masters at optimization. So the first step being determine the formula of the function that you need to optimize. So let's say that we have the problem asking us to find the maximum area of a rectangle whose perimeter is 400 yards. So if you heard that, we have the maximum perimeter of 400 yards. That means our constraint is equal to 400. And we heard a rectangle, so that means our area is going to be length times width. We also know the perimeter of a rectangle is equal to 2L plus 2W. So just like that, we have our first step done. This is actually the most difficult part of the problem because the setup will determine if you get the problem right. So the second step is to identify the constraints, which we already did in the first step because that is also an important part. But what is also important to note about this constraint is that it can vary from being the area or the perimeter. So say we are given the constraint of 1,600 cubic yards, or 1,600 square yards, or 1,600 feet. Though the units that we are given are very important because we can say 1,600 yards cubed is equal to the volume constraint, whereas the 1,600 yards squared is equal to the area constraint. But in this situation, we are given 400 yards, and that is equal to the perimeter constraint. So now we are going to try to express the function in terms of a single variable upon which it depends. And that means that we are going to look at the perimeter, which is equal to 2L, or 2 times the length plus 2 times the width. And we know our constraint is 400 yards, and that is equal to 2L plus 2W. We can divide by 2 and get 200 is equal to L plus W. And for this case, we are going to subtract over, the width. And so we're going to say 200 minus W is equal to our L. And now we can move on to step 4. We can say that A is equal to L times W. And what we just figured out is that L is equal to W minus 200, or 200 minus W, my apologies. And that means we can substitute that in and say 200 minus W times W is equal to 200W minus W squared, and that is our area. But what we want to do is find the critical points. If you recall how to find the maximum of any function, is find the maximum point of area. This means we are going to take the derivative of the area function and say that area is equal to 200 minus 2W. Then we're going to set area equal to 0 for step 5. So that means 0 is equal to 200 minus 2W, and that means 2W is equal to 200, and W is equal to 100. And we're going to plug that back into our perimeter formula and say that P is equal to 2L plus 200, and we're going to put back our constraint, 400 minus 200 equals 2L, and so L is equal to 100 as well. So we can kind of visualize this. Our rectangle is looking something like this. Our rectangle is looking a lot like a square. It's 100 by 100. And now what we want to do is find the area, or the maximum yards and the maximum length. We know the maximum length of each side is going to be 100 because we are given 400 yards, and that means that each side is going to be 400. But we know that since each side is going to be 100 yards, the maximum area, which is what the problem is asking for, is going to be length times width, which is also 100 times 100, which is equal to 10,000 yards squared. And that is how you optimize a function, or the area. I hope that helps, and if you need more assistance, there is a bunch of problems on the website and assistance there. Thank you.